I want to show you guys how to do it, and what I want to do is leave you the last step or two to do on your own and see if you can figure out the direction, figure out where is the treasure, and find out where it is in terms of the direction and the length from the origin. Okay, so this is on 273. Okay, and here's how we're going to do this. You have to have SB page 273. You need to have this out in front of you. Okay, right here. Going in order. Okay, so I'm going to kind of literally walk you guys through, okay? Okay. Basically, this has a starting point, okay? And then it works through. Every single case, what you're kind of be thinking is, what is theta at that particular time? And then, what is the length of the vector? And that's how we're going to figure out where you are without having to graph it. And the old way with geometry would have been really ridiculous. You'll see in a moment. This is actually not that difficult, okay? We did talk about that at the start, theta is 0, and of course, the length is 0, right? So you could say our A, B coordinates, and of course this could be your I and J, right? I plus J, if you're doing that notation, right? It's either this or this is going to be 0. I'm going to do it plus. I'm going to do the I and J, okay? Because at some point you really are going to be adding these. Step 3. Step 2, this is step 1 and 2. This is the old skull rather. This is number 2. Step 3 says go north 100 feet. Theta becomes what?
0.
Go north. 90. Now theta is 90 degrees. So here, theta is 90 degrees and I went 100 feet. Okay? You already know that you should be at 0 and 100. Does everybody see that? But notice that the math will prove this out. What I'm going to do is I'm going to say this is 100 times the cosine of 90 degrees plus, I'm going to give myself a little more room here, okay, plus the sine of 90 degrees. Okay, what does that equal? What is the cosine of 90 degrees? 0.
0.
Okay? And what is the sine of 90 degrees? So it's 100. Okay, so you can figure that out without trig, because at the 90-degree angles, we can use a plane. But this is where it starts to get a little bit dicier. When it says turn 40 degrees counterclockwise, now where am I in terms of theta? Just think theta. Well, I'm here, 40 more degrees is going to be 130. So now, theta, I had to add 40 degrees, right? Theta's now 130. This is where trig is going to come into play. You'll need a calculator for this. And how far did I go? 300 feet. Okay? Right? So it's going to be 300 times the cosine of 130 plus the sine of 130. Okay. Work that out with a calculator. Come up with that, right? You could actually just come up with that plus that, multiply by 3. Well, actually, you can't do that because you need to break this up. Never mind. You're going to do that, and then you're going to do that. We want to keep it in the 2 component forms, okay? So what I end up with, I believe, make sure you can do this, right? Is this correct? I think I got this one here. Because now I have an odd angle, right? Okay, that's what I believe you can come up with a calculator, okay? I'm not gonna go all the way to the end. I'm gonna get you one more. I went this far quickly in class, but it was too fast, I know that. So we're gonna go through one more step here, okay? It says in step 6, turn 80 degrees clockwise. That's the other way.
Yeah.
So what is theta now?
50.
Yeah. Because I'm going in the opposite direction, I'm reversing some of my turn. Theta is now 50 degrees. And how far am I going? Another 300 feet. So here's what I'm going to add. Okay, every time I move, I'm adding my vector. It's going to be 300 times the cosine of 50 degrees, right? I'm going to write it this way. Plus 300 times the sine of 50 degrees. What? Okay, so I need to come up with this and add it to this. Where am I? See,
Subtractive.
yeah, that's what, this is going to zero out. This will be, that should make sense, by the way, that the cosine of one, yep, so this is all gonna, yep, so
Whoa.
these are going to zero out, plus, and you're gonna be left with,
569.
there we go, all right? So we're adding this, 559.6, I'm doing I and J. Yeah, this is I, this is J, this is I, and this is J. Okay? All right? Do you guys see what you're doing? Okay? Maybe I'll do the one last step here. Turn to face east. Where's theta now? Turn to face east.
Would we be at 180 degrees?
East. Oh, you're turning left.
You're going the back. Yeah, you're turning. Now you're turning to face east.
Wait, but we have to say R loudly.
If you turn to face east, you're automatically at east is 0. So now theta is 0. And now notice I am not walking from here to here. I'm somewhere over here walking. You know what I mean? Okay. Actually, if X is, I'm here walking over here, but I'm up the 559.6 feet. Okay. I think these are all feet, right? So essentially, by the way, just so you understand what this means on the ABI plane, X, my A part is 0, my I part, I'm up here I'm basically at almost 560, right? And now I'm turning to go east, and I'm going to go, how many? 700 feet. So I'm going to go 700 feet. If you understand what that means, do I need to crank through a trigonometric equation here?
No.
What do I have? What should I have here? I should have 700 plus, I didn't change my, right? But if I do the math, you will see, right, that I got 700 feet. If I take 700 times the cosine of 0 plus the sine of 0, right? Well, that's going to be 1, that's going to be 0, multiply by 1, I get that, nothing added there. I'm adding on, okay? So, I'm going to have you finish the last step, okay? And then when you finish the last step, down at the bottom, I'm not going to put the key to this. I want you to figure this out. You're going to get a direction. That means that for whatever, notice this is like an X and this is like a Y. To get a direction or a bearing, we're looking for theta. Theta is, right, the tan, so get the tan of theta by this, tan of this over this, right? Okay? Right? Pretty simple. And then if I want the distance, it's the Pythagorean theorem again, okay? All right? And then I'll go over. If you have questions on that on Monday, if you can't figure that, but I would encourage you to try to figure that out. You have all the math you need to do this, okay? All right,